And this is going to be kind of bigger in scope than you would get from a class, but the reason I'm going to do it now is because I'm going to do it in front of you. If you want, I highly encourage you to not watch the whole video if you want to try doing it on your own. I encourage you to try doing it on your own. If you have trouble, then if you want to go and find out how to do it from websites or from watching another few minutes of this video to maybe see how I do it, that's fine too. Or if you don't want to do it yourself, just watch the video and maybe you'll learn by watching. So here is the problem that we are going to solve. Here is the project that we are going to implement. The first thing I'm going to do is I'm going to delete these guys. Actually, no, what I'm going to do is I'm going to make a new package. We're going to do something called the checkmate checker. You can probably guess where this is going. And I'm going to make a class called main. Okay, so I'm going to get rid of these because you don't really need them. Alright. Can I do a... Alright. So here is the problem that we are going to solve. Hopefully you all know about chess and how chess is played and the rules. Doesn't matter if you're good or not. What matters is you know how chess is played. Now, a chess game ends in two ways. There are two ways for a chess game to end. Number one is it can end in a stalemate. Actually, there are three ways it can end. One is it can end in a stalemate, where neither player is able to win. Maybe they both have their king, and one player has a bishop on white, and the other person just moves his king on black, right? So you can have... I just started our mini project. I just finished a little shorter video on string manipulation. So I was talking about char-at, I was talking about substrings, and I introduced regex. But it was a pretty short video. It's a video that I did because we may or may not need it for this one, depending on how people are going to do it. So our project is, we are going to create a system where we can represent a chessboard and the pieces on it. And we're going to do this using, you can use a string or you can use an array. Either one doesn't really matter. I'm going to use an array of characters. And the problem we have is, given a certain game state, given a particular game state in chess, I'm reading chat real quick, so maybe I'll read it later while I explain the problem, so I don't have to restart. Our problem is, given a particular game state of chess, so given the positions of different pieces on the board, our program is going to determine whether a player has checkmated their opponent. Or actually, how about if they've just checked their opponent? Not checkmate, just check. So check means one person's king is in the path of the other person's units. We're not going to care about whose turn it is for this, okay? So for example, if there's a king and there's a rook 3 spaces directly above with nothing in between, that would be check. If there's a king and there's a rook 3 spaces above but something's in between them, that is not check. Okay, so we're going to take a particular game state of chess and we're going to write our program to figure out if either king is in check. That's all we're going to do. Okay, so if you want to try this yourself, don't watch the rest of the video yet. Go ahead and try it on your own. Give yourself probably a few hours if you're new. If you've done some Java stuff before, probably shouldn't take you too long. It definitely shouldn't take over a day. And if you get completely lost, then just come back. Okay, now I'm going to read chat real quick. Super over chunking a string into words. Regex version, which needed one line, needed 3,000. Oh yes, okay. I think I understand what 121GW is talking about. He basically wrote his own syntax engine, something like nope, in here. Yes, he probably wrote something like this. This is a class that that basically reads different script functions and figures out what they do. He wrote basically his own regex engine, And the reason that yours likely took less bytes is because the regex engine has a lot of stuff in it. Yours probably had less stuff in it, right? I'm assuming, because you probably weren't using like back references or anything like that. The regex engine has a lot of stuff it has to check, but you can specialize your program to be faster and smaller. But if you don't have the time to do that, then regex is just fine. So anyway, we're gonna start this project. I'm gonna close this thing over here because we don't need it. All right. So the first thing I'm gonna do is I'm going to, you know what? I'm gonna do this with only one class. I'm not gonna make any objects. I could make a game state object, but I'm not going to. Okay. We're gonna do this in one class for me. You don't have to do it this way. So the way I'm going to do this is I'm going to have a character array. Okay, this is a two-dimensional array. So if you imagine, maybe I'll name it first. Board equals new char. And it's going to be 8 by 8, of course, because those are the dimensions of a standard chessboard. So if you remember, an array looks like this, right? So this is an array with 4 compartments. A two-dimensional array, I don't know why I typed that. A two-dimensional array would look like this. So this would be a 4 by 4 array. And I hate when it does that. So as you can see, this is a pretty good way to represent a chessboard, because the chessboard is laid out exactly like this. So compartment 0, 0 would be this one, and this would be 1, 0. I mean, it doesn't matter if you go horizontal or vertical first. And then on the other end, we would get, actually 3, 3 would be down here. Alright, so that's what we're going to do. We're going to have a two-dimensional array that's going to be 8 by 8. So the first thing we're going to do is, I don't actually have... Actually, here's what I'm going to do. I'm going to actually make my board state right here. I'm going to have to put spaces in here. I'm going to set up the array manually when it is created. And I can put commas here, not on this one, and that's the end of that. Okay, here's our chessboard. It looks a little weird. This is how you initialize an array of primitives. I don't believe you can do this with objects, but you can do it with primitives. And characters are primitives. So each row is one of the inner arrays, and the vertical, like these brackets on the outside, are for the outer array. So we have an 8 by 8, I believe this is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. We have an 8 by 8 array, and it's completely blank right now. So we're going to leave our chessboard blank for now, and we're going to write our code first. So the first thing I'm going to do is I'm going to make a bunch of methods. I haven't planned this, I just thought of the idea to do this. So I don't actually know exactly how I'm going to do it, but I have a pretty good idea. The way I'm going to start is I'm going to write some of my methods first, some of my utility methods. So the methods I'm going to make are in range of knight. Actually, how about this? In range of king. No, let's do knight. We're not going to make king's attack. And we're going to take something on the x-axis, and we'll take something on the y-axis. So here's what this function, or this method, is going to do. Let's say I'm looking at this space right here. I want to know if this space is under attack by a knight. That means there's going to be a knight in this one, this one, this one, this one. I'm not going to highlight them all. So this one method is going to return true if a knight can attack this spot. And the reason I chose knight first is because we don't have to worry about things in the way. Knights jump over other units. So what I'm going to do is, except for spaces near the sides, a knight can attack from 8 spots. I don't want to write them out like that, though. Maybe I do. Yeah, I'll write it out so it's easier to understand. Okay. So spot1 equals x minus 1 y plus 2. Okay, so this means, and the way I'm going to measure this is the x-axis. So this would be 0, 1, 2, 3, 4, 5, and going up is the y-axis. So this down here would be 0, 0, and this is going to be 8, 8. That's how I'm going to measure this. You can assign any coordinate system you want and it will still work as long as it's consistent. So you can do 0, 0 up here and 8, 8 down here. It doesn't really matter. I'm choosing to do it like it is on a number plane because I'm good at math and I'm used to that. Okay, so that's spot 1. Int spot 2 equals, actually, why don't I do it like this? I'm thinking if I want to store them as characters, like I want to get which characters are in those spaces. No, I think yeah, let's do it by character. So character in spot 1 is going to be board x minus 1 y plus 2, but we're going to have a problem. Did I do that right? Why is it complaining? Why are you complaining? Incompatible types, character array cannot be, oh. Oh, it's because I didn't do this. That's what we want. Actually, this is going to be flipped upside down, isn't it? Because I put the x first. It doesn't matter, as long as it's consistent. Alright, now we're going to have a problem, though. Because if we are on this space and we try to do a y plus 2, we're going to go out of bounds. Okay? So, I did not teach try-catch. Oh, I forgot to do that. Alright, I'm going to quickly teach you try-catch in Java. Let's say that you know your code is going to run into a problem, but you decide that it's acceptable. In this case, it is acceptable. We're trying to find spots a knight could attack from, but if we're near the edge of the board, that might be outside the board. But we understand that that's okay, and we don't want our program to explode. So the way you do this is you type try, and you open a code block. That's what the braces mean. And you put your dangerous code inside the block. At the end of the block, you write catch, but you spell it correctly, unlike me. Then you specify what type of exception you're expecting. So in this case, we're expecting an index, actually, what is it called? Array index out of bounds exception. E. Just like a parameter. So this is the type, and the variable name is E. Inside the catch, you put another code block. So I'm going to explain what this code right here is doing. Let me indent this so it looks nice. So we're going to try to run this line of code. If something goes wrong, and the thing that goes wrong is this error, then we're going to run whatever's inside this block. So we might do something like sysout, it's enter now. That's outside the board. So it's going to hit this catch, it's going to run this system out print line, and it's just going to continue as though nothing happened. That's what try-catch does. It's a very useful way to anticipate errors that you deem acceptable. There are some errors that you might deem unacceptable where you want your program to crash. That's fine too. But in this case, we don't want a program to crash if a piece is near the edge of the board. Okay? So that's what this is going to do. If you don't know what kind of exception to put, if you're new and you don't know what kinds of exceptions there are, you can just catch every exception like this. Now what I'm going to do is I'm not actually going to do anything in my exception block. This is considered extremely bad practice, by the way. If anything, you're going to want to put something in these catch blocks. Like most companies would even prefer you say do nothing. Just put a comment in there where you're telling the other programmers or future programmers that you intended for this to be caught and you don't want to do anything. Okay? You should always put something in this catch block even if it's just a comment. But to save space, I'm going to put nothing in it. This is bad practice. Don't ever do it. Like I said, the only reason I'm doing it is to save space. And then we're going to copy this because, oh, my mouse is double clicking. Alright, here we go. there are 8 spots a knight can attack from, this is how it's going to go. So we're going to do y minus 2 right here. Now, you could do it this way. I'm doing it this way because it's easier to wrap your head around, especially for the newer people. But what you would actually do if you were writing real code is you would use a loop to do this. And you would be very clever in the numbers that you put into these arrays. You would loop 8 times, and you would arrange your math so that it would basically call all the things that I'm going to call. So what I'm going to do is minus 2, and then this is going to be plus 1, minus 1, plus 1, minus 1. So let's see, x minus 1, x minus 1, x plus 1, x plus 1, x minus 2, x minus 2, x plus 2, x plus 2. I think I've done that right. Except, spots. I'm going to store them as an array instead of, so bear with me real quick. I'm just going to copy this because I'm lazy. I will change those in 1 second. You can fast forward the video about 15 seconds. I messed that up. Because if I declare the variables inside this, inside these try-catch blocks, these are brackets. So anything I declare inside here is going to get lost when the try-catch finishes, and that's not what I want. Like I said, the actual correct way to do this would be to use a loop. Obviously, I said anytime you're going to copy-paste code, you should probably use a loop or make a method. But for simplicity, I'm going to, sorry, my phone went off. For simplicity, I'm going to write it out. And actually, here's what I'm going to do. I actually am going to put something in the exception. So you can see what I'm doing here. If it's out of bounds, I'm just going to treat it like there's no unit on that spot. Okay, so if we're looking if a knight can attack from way out here, I'm just going to treat it as though there's no unit there, there's no piece there. So I'm going to copy, no, just the thing inside. Here. That's 7, okay. So hopefully you've been able to figure this out, but in case you haven't, I'm going to explain what this method is doing. I haven't actually finished the method yet, because it has to return a boolean. Here's what it's doing. I'm creating an array of 8 characters, and then I'm checking one of the spots that a knight could attack from. I'm basically getting the name of the unit that's there. And the way we're going to represent things is if there's like a king, it's going to be a K. If there's a knight, we're going to make knight N, but you can make it anything. If there's a rook, it's going to be an R. You get the idea. This is how we're going to use our board. So I'm basically, let's see, spot 0. There is a way to optimize this. Maybe one of you will catch it. There's a way to greatly optimize this. So now that we've captured the 8 locations a knight could attack from, we have the characters, we have the units that are in those spaces. We're going to loop through my array. We're going to loop through our array, and we're going to check if any of them is a knight, the letter N. So for, actually we'll do it this way. For char C inside, what did I call it? Spots. If C is a knight, return true. And at the end of the method, if we haven't returned true, we return false. So now we have a method that can check if any given space, xy, is in range of a knight. We're just checking all the spaces that a knight could attack from, and we're looking for a knight. How many of you have been watching and have an idea of how I can optimize this method? Because there is a way to optimize it. I'll wait a few seconds, see if anybody has any ideas. Anybody? Okay, looks like nobody's saying anything, so I'll just show you how. Rather than having a try-catch, try-catch, try-catch every single time, I'm still not going to use a loop. But what I'm going to do Jello Ranger's on the right track. I think he knows that he's right. He just kind of said it in a way that's not very explicit. What he's saying is, rather than creating this array and then, adding 8 things to it, what I could do is, well, what if this one turns out to be true? I already have access to it. Why don't I just check it in here? So what I can do is, if this space that we already know equals night, one more. What did I do? I need to get rid of this one. Return true. So we look at this space, and if there's a night in the first space we look at, we don't even have to run the rest of this code at all. Alright, so that's what we're going to do. We still need this try catch because we still might be looking out of bounds. Okay, so what I'm going to do is I'm just going to copy this because it's much easier to change. Actually, I'll copy the whole thing because I'm lazy. I'll copy the whole try catch and just get rid of all this other stuff. I'll put spaces between them. That's 8 of them. And if we haven't hit a return true, we're just going to return false. So I need to y minus 2, y plus 2, y minus 2, y plus 1, y minus 1, y plus 1, and y minus 1. It's kind of annoying that I have to do this again, but that's alright. So x minus 1, plus 1, and plus 1, x minus 2, x minus 2, x plus 2, x plus 2. And I'm going to test this briefly. So I have a night here. I want to test if this space... I actually need to think about how the coordinate system is set up. So x is actually going to be the... that's the wrong one. That's y, and that's x. Because the first parameter is going to be which row. It's going to be which row I'm looking at. And so the x is going to be, so our y is going to be top to bottom. So this is going to be y equals 0. I should not have, yeah, that's fine. I'll just put that back there. Alright. So this row is y equals 0. But the x-axis is okay. So this is x0, 1, 2. So that's how it's going to go. So I want to see if there's a rook, this poor guy right here. So that's going to be 0, 1, 2, y equals 3. And x equals 4. So I want to try 3 and 4. Did I make that static? I didn't make it static. I have to make it static because, and I have to make this static actually. I have to make it static because I'm going to call all of this from a static method, so everything has to be static. If you were making your own objects, you would not have to do this. Hey Beeb, welcome back. In case you missed it, what we're doing is we're making a project where we have a chessboard, or a representation of one, and we want to detect if either king is in check. Actually, because we don't have a way to differentiate from the teams, we're only going to have one king on the board, and we're going to just detect if anything is putting him in check. There's no way to determine black and white on this. You could use lowercase, uppercase if you want. Maybe that would be a little extra bonus for you to do at home. But right now I'm just going to test my method. So what did I say? This was y equals 3 and x equals 4. Is that what I said? Oh, the knight is in the wrong spot. I want to test that spot. So this method should check if our rook is in danger of being eaten by this knight. So I'm going to... Yes. I should put that inside an else. Actually, I'm just going to get rid of it. So if I have coded this properly, I'm not even using this array anymore, aren't I? Shouldn't have done that. It'll be fine. Oops. I need a new mouse. Like I said, normally you would use a loop to do all this, because you can do all this in just 4 lines of code. 5 if you include this one. So this, if I have done everything properly, should print out a yes. Uh-oh, we might have a bug. 0, 1, 2, 3. 0, 1, 2, 3, 4. We've got a knight in the y minus 2, x minus 1. Make sure I did a y minus 2, yeah, this one. I'm going to debug it. Let's find out what went wrong. Invalid line breakpoint. Okay, we'll debug it here instead. Okay, so we're looking at board. Can I go down here? Okay, we're looking at what's our x? Our x is going to be 4 and our y is going to be 3. So 4 minus 1 is 3. We're looking at... oh, these need to be flipped. It shouldn't matter though, because they're all the same. So the space I want to look at is y minus 2, x minus 1. So let's find, that'll be this one. So I want to continue. Here we go. Let me just double check. X is 4, so this one's going to be 3. X equals 3. And this is going to be 1, right? 1, this is 1, 3, okay. So this should return true. If board... oh no, it's flipped because the first one needs to be y. There's another way to... which one is this equal to? The first one, I want x minus 2, y minus 1, don't I? X minus 2, y minus 1. Okay, so this one actually is the one we're looking for. The board coordinates here need to be flipped because we're going this way first and then across. So we're not actually looking at that one, we're looking at this one. So x is 4. So this is going to be looking at space 2, 2. Okay, yeah, I need to flip these. The order of these. So y, x. I'll just do it this way first. Luckily the math's right, I just put these in the wrong place. Bugs do happen. You will write bugs in your careers, even for simple things like this. This might not seem simple for some of you, but it's simple to me. Alright, so now I'm looking at y minus 2, x minus 1, which is this one. Yeah, this is correct. This is what we want. So now, let's just run it and see if we get... okay, we get a yes. That time, I did a lesson earlier about string manipulation, but now we're doing a little mini project. So if you don't want me to give away everything, just watch the video in the archive when it's done. Unfortunately, it's not there right now. We're making a program that if you give it a chessboard like this, it can detect whether the king is in check. So if I had a king down here, it would return false, because this is a rook and this is a knight. They can't attack this king. But if I put a rook up here, then it would say that the king is in check. That's what we're doing. Alright, so now we know that if I ask for this space in our little test right here, then it'll say yes. But I want to test, maybe it's always saying yes and I don't know it. So we're going to put the knight up here instead. And we're going to run it. Okay, we don't get a yes. And I'm just going to put, let's check our bounds. Our bounds checking. Is in range of knight 0, whoops, 0, 0. That's this space up here. So this should not throw any exceptions because we've used try catch all over the place down here. So this should return a yes. Okay, it looks like this method works. The in range of knight. So now what I'm going to do, now that we know this works, we're going to collapse it. If you actually, I'll leave it up on the screen for a few seconds. I wish I could kind of expand it, but you're basically copying and pasting all this. You can pause the screen if you need to catch up. But this is, maybe I'll go over what it does again. So we're giving it a y and an x coordinate. I'll explain the math behind why I had to flip those. But we're basically asking, alright, we're going to go to the first space that a knight could attack this yx space. If there's a knight on that space, then this can be attacked by a knight, so we return true. Otherwise, we keep going, and we just check all 8 spaces that the knight could attack from. And if all of these do not return true, then the last option we have is, well, no, it can't be attacked by a knight. Easiest game to program is tic-tac-toe. I disagree. The easiest game to program is flip a coin. Somebody calls heads or tails, you generate a random number, and you make them lose every time because they have no way to verify if you're cheating. Alright, so we're checking if 0-0 works, and we did not get any bounds exceptions. In fact, let's make it go through all 8 by not having a knight up there. Okay, it looks like everything's good. This method seems to work. So now what we're going to do is we're going to collapse this method since we don't need it anymore. We're not going to edit it. Now I could do this for every single unit, but I'll just do bad exception handling. What I said we should, I told them you should use the specific exception that you're expecting. In this case, it would be array index out of bounds. I also said that you should probably implement this whole method as a loop, but that requires some complex math. But I said if you don't know all the different types of exceptions, there are 2 ways to find out. You can either catch it and print it. If you want to print an exception, you put e.print stack trace. I said that you should always put something in these brackets, even if you don't intend to do anything. You should do something. You should do something like this. You should explicitly say that you're not doing anything in your catch block. This is actually acceptable in the industry. Some people don't like it, but a lot of people don't care. As long as you put something, some kind of explanation as to why there's nothing in there. I said it's very bad to have an empty catch block. I'm only doing it to save space. I have a limited space to show you guys this method. So that's why my exception handling looks bad to you, because I wanted to save space. But I promise you, if you go back and watch the whole video, I do explain why I did that. You should always put something in your catch block, even if it's just a comment. Alright, so we've got our in range of knight method. That method works. I'm not going to do every single unit because we'd be here all night. Let's do a rook, okay? Public static boolean in range of rook. Same thing. So this method is going to check whether our space yx is in danger of being attacked by a rook. This is going to be a little different than the knight, because a space can only be attacked by a rook if there's nothing in between. Right? These 3 spaces, right? Maybe I should put the rook over here. Alright, if there's nothing here, then our king is in danger of being checked. Why so many try catch? Because I didn't want to make a loop. People are joining late and I gotta explain multiple times, but that's fine. You should make a loop to generate all of these ifs. And the reason that there are so many, the reason why you can't just surround, like I can't put a try and then a 1 catch down here, is because if any of these fail, it won't do the other ones, but I want them to hit all of them. Yeah, Jello Ranger, exactly right. If one of these fails, I don't want it to jump to the false, I still want it to check the other ones. That's why the try catches have such small scope. Alright, so in range of rook. So what we're going to do, there are 2 paths that we have to check, right? If something's in range of a rook. We have to check vertical, up and down, and we have to check horizontal, left and right. Okay? So what we're going to do is we're going to have 2 blocks of code to do this. Let's make this one, I'm going to comment this, vertical check. So what we're going to do is, let's say we're checking this space, this where this king is. We're going to check every space above it and every space below it. Okay? There is a... Now we'll do it this way. Actually, is there a better way to do this? Because we do have to do a little bit of collision detection to make sure there's nothing in between. Let's do it like this. I is less than 8i++. So we're going to start at whatever coordinate our space is at. So if we're starting here, the logic I'm going to do, I'll tell you before I code it, is we're going to start at this space, and we're just going to go 1 space down, and then we're going to go another space down, and then we're going to go another space down. Actually, we're going to stop at the end of the grid, which is y is going to equal 7. So this is the last space we'll check going down. We're going to have another loop that's going to check all the way up. And just like what we're doing down here, if we hit a space that has a unit and it's not a rook, we're going to return false immediately. We're not even going to run the rest of the code. So do you guys understand what's going to happen? So if I want to check if this space is in trouble, is in risk of being hit by a rook, we're just going to go up one space. If it's a rook, return true. If it's blank, keep going. If it's anything else, return false. Then we're going to up again if it's blank. If it's a rook, return true. If it's anything else, return false. Then we're going to go up here, and so on and so forth. That's how we're going to do this logic. Okay? So I equals y. So we're going from y to 8. If board is what I called it, I, not y. And this is going to be x. X will not change. We're always looking at the same column. Equals a rook. Return true. You should always put things in your if statement in brackets. This is good practice. Yes, this will be uploaded to YouTube when it's done. Actually, I should probably do the other ones as well. But these will all be on YouTube eventually when I have time to do it. That's kind of a cop-out, right? It takes like 5 seconds to go from Twitch to YouTube. So we're going to check the space below as y gets bigger. Remember, y is 0 up here, so as y gets bigger, we go down. We're going to check the space below. Actually, we need to do a y plus 1. Because we're not going to check the space that the king is on. Hey, Sput, look. We're making a program that detects whether a particular spot is in check. Alright, so we're going to go down. We're going to check if there's a rook below. If there is, we return true. If that spot, the same spot we're looking at, equals a space, we're going to use the continue keyword. Continue means end the loop, but go back here. Not jump out of the loop. It means restart on the next iteration. It's kind of like a break. Alright? So continue, and if you highlight it, it should tell you it's going to continue on this 4. Let me highlight something else so you can... It's not going to do it at all. What happened? I'm getting a syntax error. Is it because I'm not returning anything? Alright. I should create constants for these characters. I should. In fact, that's a very good idea. Why don't I do it? Oh, the problem with that, actually, is I'll have to type my constants in here, and it throws off the alignment of the grid. So if I was doing like a high-quality production program, I would do that. That's exactly what I would do. Anything that's not going to change and that always has the same meaning should be a constant. But because this is kind of like a how-to-do video, this is much easier to understand. So we're just going to stick with this. So we're going to check if the space has a rook. Again, our logic is we're going to start on whatever space we were asking for, and we're going to check the space under it. If it's a rook, return true. If it's blank, keep going. If it's anything else, return false. Okay? So that is the first of 4 loops. Sometimes I just want to bang my head into a wall because I can't find out the error. Yeah, sometimes that happens. And sometimes when you do find it, you realize it's really simple and then you are mad at yourself even more, right? Alright, so now this loop only checks at our starting point and looking down. So this spot and this spot. So we need to make another loop that's exactly the same, but it looks up. So we're going to start at y minus 1. I is greater than or equal to 0. I minus minus. And our logic for this loop is exactly the same. Could you go out of bounds? Not on this, because every time we loop, we're checking if we're out of bounds. That's why this I less than 8 and the I greater than or equal to 0 is right here. So these loops cannot go out of bounds unless these numbers are out of bounds. Okay, if we're passing in like y equals 10, then we'll get an exception here. But the way I'm going to write the rest of the program is this will never happen. These will always be between 0 and 8. Yeah, 0 and 7. Alright, so we're going to copy these. So that's the vertical check down. I'll comment these. Vertical check, check up. The reason why I misspell things a lot while typing is because typing and speaking is really hard, it turns out. Horizontal check right. So as we go right, X is going to be bigger. So we're going to start at, come on. Ignore the loop on the bottom for now. Ignore this thing because we're going to change. Actually, I'm just going to get rid of it because we don't need it right now. If you pass Y as 7, will it go through the loop? I believe it will actually check this when you start the loop. No, that's not right. It will check this when you start the loop. If I set I equals 100 while I is less than 5, it won't actually run the loop. So yeah, actually this will not throw any, it still might throw exceptions, because if X is out of bounds and Y is in bounds, it will still try to do this. So we'll still get exceptions. Yeah, but I'm gonna limit them between 0 and 7 in the rest of my code when I actually do it. So int I equals X plus 1, I is less than 8. So this is gonna be board Y I. It's exactly the same logic, we're just flipping it for the x-axis. I'm going to copy this. I think I've done that right. This is going to be the horizontal check left, where we're going to do I minus minus. I'll scroll up a little bit. I greater than or equal to 0. And this is x minus 1. What does bounce mean? Where are you seeing bounce? Oh, did somebody ask something? I don't see a bounce. Are you talking about board? Board is the name of my chessboard. I don't see a bounce anywhere in here. I'm trying to read chat to see if somebody else has said bounce, but I don't see it. Sputlook asks, what does bounce mean? I guess I'll wait until he elaborates on that question. Alright, so I think we've finished our logic. We're checking vertically whether we've run into a rook. Oh, out of bounds. B-O-U-N-D-S. Out of bounds. That means, yeah, people caught it. That means if I have an array, in fact, I'll do it in my main method. We're going to get rid of this. If I have an array, not 54, let's do 5. And I try to ask, I do array at slot 8 equals C, I'm going to get an exception. It's going to be an, yeah, that's fine. Wait, I have a compile error. Oh. Okay. Now I'll run it. We have compile error, and we have, let me make this bigger. We have an array index out of bounds exception. That's how it's spelled. That just means that we've tried to access part of the array that is outside of our defined array. Okay, so I think that I have finished our checking for rook. So now I'm going to test it. So right now on this board, this king is in danger of being hit by this rook, right? So we're gonna test that. So this is y equals 0, 1, 2, 3, 4, 5. So the y is 5 and the x is 0, 1, 2, 3, 4, 5, 6. We're just going to say yes. Otherwise, we're not going to say anything. So this should print a yes. We got a yes. Alright, let's move the rook. It's like up here maybe. Now we should not get anything. Very good. When you're testing things, it's important to test as many cases as you can think of. So we're going to test the vertical, test the horizontal, test whether there's no rook. In a second, I'm going to test if a unit's in the way. Okay, yes, that is in range. Let's put a pawn right here. Can this rook attack this king now? No. Okay, looks like we're in good shape. I'm going to clear these out. And do I want to do one more? What window am I using? What are you talking about? What window am I using? Yes, in bigger projects you would use a JUnit test, or you'd use a reflection test, which is what I sometimes use. But I didn't want to make another class, so that's why. I could make a JUnit test right now, but that's not really in the scope of this video. A JUnit test, for those who may not know, there's this library called JUnit, and there are a bunch of other ones like AssertJ, which is better than JUnit, where you can write a single method, and that method checks something. Like you write to, you write your code. If you're expecting it to pass, you tell it, I'm expecting that code to pass. If you're expecting it to fail, you tell it, I'm expecting it to fail. And you just run that file, or sometimes if it's a really big project, you can make it run every test in your project. And it will give you like a report of which tests passed and which tests failed, and it'll tell you if any exceptions happened, it'll tell you where. It's really neat. But we're not going to do that. These are pretty simple, so these are what we call an integration test, where anytime there's human verification, it's an integration test. JUnit or AssertJ, they're called unit tests. Those should automatically check whether something works or not. There shouldn't be any human waiting there seeing if something's working. I'm going to go through these questions because there are a few now. Oh, which Windows operating system am I using? This is Windows 7. Yeah, this is Windows 7. Trickster Joe version 2 asks, hi, something that's been bothering me for quite some time is relying on an API. Is that what you're talking about? Relying? You kind of spelled it weird. Relaying or relying? Is relying on an API considered bad programming practice? Is it I don't know which word you were trying to go for, because it could be either one. Well, I'm going to answer the question that I think you asked, which is, should you rely on APIs, or is it, he says, yeah, but I don't know which one it is. Relaying or relying, help me out. And even if it's relying, I'm not quite sure I understand what your question is. Do you mean, should you trust APIs? Is that what you mean? Should you trust what an API says? An API is basically when someone makes a library, a code library, they usually give you some documentation when they release it. And this is the API. It's basically a list of all the classes and all of the methods that you can use to use their code. That's what an API is. So let's say that I was programming, instead of just writing this program for me, what if I was writing this program to be a library? If chess was like super duper huge, I could write a library where somebody else could use their chessboard and they'd be able to ask my code, is something in check? I think he's asking, is it safe to rely, to trust other people's APIs? And my answer is no. You should not trust APIs, because quite often they will have bugs. You can assume reasonably that they will work most of the time. Usually people that make specialized APIs are very good at what they do. So usually their code is very good, very high quality, error-proof, but not always. Everyone's human, everyone makes mistakes. There are bugs in basically anything. Oh, I see what he's asking. He's asking, should you... He just elaborated. He's saying, instead of doing stuff from scratch, should you use APIs? One thing you'll learn if you take classes, I'm sure, if you take programming classes or software design classes, is if there's an existing library out there that does what you want, use it. Okay, if there's something that already exists, use it. Especially if you're working at a company. The company doesn't want to spend the time and the money to have their own employees make something that may not be as good as what already exists. If there's something that's really good and that's, that a lot of people use out there in the world, then go ahead and use it. The learning curve required for most APIs, it's not flat, but it's not usually that high either. it's much cheaper for companies or even for individuals if you're working on indie projects. It's much cheaper and takes less time to learn an API than it does to write your own. However, sometimes you have to write your own. Sometimes there's nothing else out there that does what you want. So if there's an API and it does exactly what you want, just use it. It's fine. But assume that it's not perfect. Okay, you should never trust it to be perfect, because if you assume that other people's code is perfect and you run into a bug, it may not be your fault. You may not have written a bug, it might be somebody else's bug. Alright, I'm glad that's the answer you wanted. Alright, so we've done our in range of knight and our in range of rook. I'm trying to think. Let's see, we've got bishops and pawns. I'm not going to do pawns because there's not really a forward on this thing. I could do bishops, I could do queens. There's not really much else on the chessboard, is there? I think we're just going to do these two. Okay? And so what I'm going to do is I'm going to... Do I think Windows 10 is good for programming? I would give you the answer if I had used Windows 10, but I have not used Windows 10 actually. The Windows on this computer is 7, on my laptop it's Windows 8. I had the offer to use Windows 10 and I turned it down because I've used Microsoft's products before. When Microsoft releases a product and says it's ready for the public to use, what that means is this product will break a lot, but come 3 years from now, you'll be able to use it. Okay? Anything Microsoft releases, don't use for 3 years. That's my rule of thumb. You can follow that if you want, but literally every single operating system they've ever made has had lots of problems for a couple years after they've released it. So I know a lot of people who got Windows 10 and then in less than 24 hours they ungot Windows 10. I know a lot of people who have done that. So I don't even get Windows' upgrades anymore. I wait a few years. I'll get Windows 10 someday, I'm sure, but not today. Alright, so I'm not going to do all the pieces. I could do a bishop. I don't only use Java, but Java is my language of choice. It's what I've done the most. I do a little bit of C, C++, a bunch of scripting languages, JavaScript, Ruby. I used to do a lot of Ruby, not so much anymore. But Java's my preferred language. It's just what I'm used to. I know the API really well. So we've made the rook rule and we've made the knight rule. You can do the bishop rule if you want. You can do the queen. Actually, if you do the queen, if you do the bishop, you don't really have to do the queen, because when you're checking a queen, you just check, is it a bishop or a queen? Is it a bishop or a rook, right? It's just a combination of those two. But there are no other pieces we want to check. So now what I'm going to do is I'm going to populate the board. I'm not going to actually use this thing directly. What I'm going to do is all I'm allowed to access is my board for this main method. I don't actually know what's on the board. So imagine this is covered up after I populate it. I'm not going to know what space the king is on. I'm going to have to find it. So we're going to put a rook there. We're going to put a bishop here, even though bishops don't have rules. We're going to put a knight here. And we're going to put another rook over here. Alright. So for this board state, obviously this rook can hit the king. So when I finish writing my find the king and then calculate it, then it should return the king is in check. So here's our main method. I'm going to scroll down so I can't see that grid. Or maybe, no, I'll scroll up so you guys can see it, because it'll probably help you. Okay. Let's see. Here's how I'm going to store where the king is. Actually, here's what I'm going to do. Int king x, king y. Here's how I'm going to store where the king is. And these, in Java, if you're using primitives, they have default values. So if you don't define them, like this, I haven't defined either of them, integers default to 0. So I don't actually want that. I want -1. Because 0 is a legit space on the board. It's this one. And you can define multiple variables by putting a comma between them if they're the same type. This is exactly the same thing as doing this. Alright. I'm going to loop through the entire array. You'll do multiple nested loops a lot in your career. So we're going from 0 to 7 on both axes now. If board y x. I'll name them y and x because it makes more sense that way. If board y x equals king, then king x equals x, and king y equals y, and I'm not going to do break. This will only be true once. I'm not going to terminate the loop explicitly. I could, but I'm not going to. And then, alright, so we've gone through our loop and we've found our king, hopefully, if he exists. The first thing I'm going to do is I'm going to make sure we know where our king is. All positives are placed on the board. All positives are placed on the board. You mean all the board coordinates? Yes, the way that I have defined my board is this is y equals 0, this is y equals 7. So 0's up here, this is row 0, row 1, row 2, etc. And the x goes up as you go right. So this first column is x equals 0, x equals 1. So yes, every space on the board is positive between 0 and 7. So yeah, if I had left these default, then that would be this space. But if there's no king on the board, I want it to be bogus. I want it to be something that's out of bounds. King is at actually, I'll do printf. Printf. I didn't used to use printf a lot because I didn't know how, but now that I know how, I'm going to use it a lot more. King y, king x is at, and I think to use a integer, it's %d. I believe that's right. I believe this will work. So this should say he's at, let's see, y equals 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 6. I think he's at 5, 6. King is at 5, 6. Excellent. Am I going to make a full chess engine? Not in this class. Actually, maybe. A chess, even though chess is a really deep game, the rules are pretty shallow, right? I mean, every turn, the only things you have to check are, is a space blocked, and is your king in check? Those are really the only two things that limit your choices, right? Is a space blocked, like is a space between your rook and something else, or is your king in check? Those are really the only two rules you have to implement. After that, the rest of the game, players can just do what they want, mostly. So a chess engine would be pretty easy to do. Maybe I will do it, but I won't do it this week. Maybe sometime in the future. And there's actually one more. I want a new line. This \n, this is an escape character for the new line character, or the return character. There are a lot of names for it. In fact, new line and return are actually different characters, but they do the same thing in most contexts. So king is at 5, 6. Okay, that's what we want. So now we know where our king is. Bitboards. I've never heard of bitboards. What is that? So the way I'm going to do the rest of this is I'm just going to check one by one. Is he in range of a knight? Is he in range of a rook? If I had the other methods, like in range of a bishop, I would check those too. But I only did these two. So if in range... Oh, actually there's one thing I have to do first. If king y equals -1 or king x equals -1, we want to end our program. That's not a valid space. And then return. Return will end our main method and effectively stop the program. Bitboards represents the chess pieces as a 64-bit integer. Yeah, you could do that. That's actually kind of cool. You can get a really clever bit math that nobody else can understand, but that is pretty cool. All right, so this is the check to make sure that our king is actually on the board. So I'm going to take this out very quickly, and I'm going to test what I just did. It shouldn't print out now because our king is on the board, but if I take him off, then we should get an error. King is at -1, -1. That's not a valid space. Okay, good. I Love Gaming says, at school when I was a child, I always used to not talk to my classmates because I used to program, and there was no one to talk to about programming until high school. Yeah. It was hard for me, like, because I started programming around 14, in the Neverwinter Nights engine, which is a game if you don't know. And that was middle school, I guess. So through middle school and all of high school, I was doing scripting, not really programming. I was doing scripting, but I didn't really have anybody to, to get excited with. That did change in college when I got to the programming classes, though. That's good. I'm glad you're at the age now where you have people to talk to. It's wonderful talking to other programmers, isn't it? It's a lot of fun. Alright, so we've checked whether our king is on the board. And now we're just going to go through each function one by one. We know where our king is. He's at king y, king x. And we're gonna print a little thing. The king is in danger of a rook. We're going to keep going, actually, because it's possible you can be in check by multiple things. So in range of knight. In danger of a... Or actually in check. Check by a rook. Is in check by a knight-rook. A knight. Alright. So now let's see what we say. Uh-oh, he should be in range of a rook. There's one right here. King y, king x. It looks like I might have to debug it, because that should have returned, this should return true. Let's go ahead and find out what went wrong. I'm going to debug it here. Alright, so our king y we've determined is 5 and 6. So 0, 1, 2, 3, 4, 5. And this is position 6, so our king is definitely in the right place. Oh, you know what I've done? Wait, yeah, I do have access to the board. So we're going to jump into this function, in range of rook. Which one? I want the horizontal going left. Oh, here's my mistake. There's actually a bug that I didn't catch. When we get here, we don't actually want to return false inside of this, because what it's doing is it's saying, all right, check going down. All right, keep going, keep going. There's no rook going down, return false. It's not even going to check going up. It's not even going to check the horizontal. So we don't want those return falses at the end of each of these. We do want it at the very end, if nothing else is true. Okay. So now it should work. It's only in range of a rook. Alright, and it is. So now what I'm going to do is I'm going to move this knight over here. That'll put him in check by a knight and a rook. Detecting checkmate was a little bit... CCA Beeb asked something before. Oh no, I missed it. Let me scroll up, so because I'm going to give him the credit. Your return false is false inside the for or. Yeah, I missed that. I didn't see that line of chat. Yeah, if you want, Linux is really good. Linux is probably the best operating system that there is that's publicly available. The problem is the user interface is kind of weird. I mean, you can get something like Ubuntu where it's similar to Mac, but programs are written for Windows. Most programs are written for Windows. So there's not a lot you can do for other programs on Linux. That's the reason I use Windows, is because I play a lot of PC games, and most PC games do not run on Linux. If all games ran on Linux, I would never use Windows again. Alright, so have I run this? Okay, king is in check by a rook, king is in check by a knight. What I could have done, if I wanted to make this really sophisticated, is these methods, rather than returning true or false, I could have made them actually tell you what space the rook is at, if there was a rook that could hit this space. I could have done that. Instead of returning a boolean, I would just return an integer array. It would always be two long, one for the x value and one for the y value. I could make my chess thing so much cooler. But all I wanted to do is challenge you guys with I guess, a medium difficulty project that I finished in a little over an hour. See, it didn't take that long. Yeah, if all you do is programming, if all you care about is programming and making cool stuff, and all you're going to use is Linux, then Linux is just fine. Linux is probably the best thing. Um, but like I said, I'm a PC gamer, that's why I'm on Windows. It's because most of my games do not work on Linux. There are people who do Linux kernel hacking. I will never understand why. This is Java. This whole series, some of them are highlighted on Twitch right now, but they will all be uploaded to YouTube one day. These are all introductory Java programming things. And we have just finished our first little mini class project where we have written a program. Mine's only 115 lines long. Our program takes a chessboard that looks like this. Each character is a piece, and it determines whether the king is in check. That's what this whole program does. It's just over 100 lines. It could be way less because this could just be a loop. This method right here could be a loop that's 4 or 5 lines long. But and I only did rook and knight. I'm only checking whether rooks and knights can hit the king, because the other pieces are basically the same. The logic is the same. I didn't want to take too much time finishing it. So we have just finished our, if chess only had 3 different types of pieces, would a king be in check? Do I have a class for each character? I chose not to make any classes except for this one. You definitely could do that. You can have an array of pieces where maybe null would represent a space is empty. You could have an object representing the entire board that contains those pieces. You can do it that way. I chose to do it in one file because it's probably the shortest way you can do it. I didn't want to deal with classes and objects too much, because for new people, even though they should get practice with it, it can be kind of hard to wrap their head around, especially the difference between a class and an object. If you were watching yesterday, my buddy AJ, he's learning to program, and he had a lot of trouble distinguishing when is it a class, when is it an object, especially when sending in parameters. But you're right, I could have made a class that represented the entire board, the entire game state. I could have made a class for each piece, or I could have made a class for all pieces, just one. And each of those, I could have even made a class for each space if I wanted to. I could have like a really complex, like interconnected series of space objects that could see each other, like a 2-dimensional linked list. I could have done that. I chose not to. This is a very simple way. This is a very naive way of doing it. But it makes the code really short. Just over 100 lines. To detect whether a king is in check. Only 100 lines of code. Does anybody have any questions on why I did something, or general programming questions? Because that's all I had tonight. Yeah, I mean, C++ and Java classes look similar, except for the way that methods are defined. I know that in C++, it's been a while since I've done it, so remind me. In C++, if I had an object like a chessboard, a method would look like is rook, you know. It looks like this, right? With the double colon. I believe that's how you write a method in C++. It's been a while, though. Few weeks into C++. Are they starting you on C++? Most places start with Java because classes in C++ look very similar, but in Java you have to use them, and in C++ they're optional. They started you with C++. Wow. In most places, at least in the States, they usually teach Java first. Number one, because it is the most popular language, and number two, because it saves you from your mistakes. In C and C++, it's very easy to get memory leaks, and null pointers, and and dereference errors and things like that. Python is a nice, solid scripting language. Python's a good one to start with, and it has a very similar structure to Java and C. My first language was a scripting language called Neverwinter Script for the game Neverwinter Nights. Guess where they got the name from? That was very similar to C. The way I usually describe it to people is Neverwinter Script is C without pointers. It has objects, but it makes them for you. But everything else about it is exactly C. They dodge the issue of memory leaks. C++ is the beginner course and the AP course is Java? Oh man. That's kind of crazy. I don't know if I agree with that. Especially since C++ is like a mix mash of C and other stuff. This week I streamed every day except Monday, I believe. I'm gonna finish up kind of the introductory stuff. I don't know if I'll do it tomorrow, maybe next week. But, I mean, you guys really like this stuff. A lot of people have told me they want to see me do more intermediate and advanced stuff. As long as you guys want it, I'll keep doing it. When I do it, it's going to be around 6:30 or 7 o'clock Central US time, which would be an hour or an hour and a half ago, roughly. A lot of people starting on C++ in the States. That's really surprising. Everywhere I've heard, and every program that I've looked at, even in like high school and middle school where they're trying to teach programming, they usually teach Java first. I can't believe they're teaching you C and they're not teaching you about memory leaks. Do they make you do malloc and dealloc, or malloc and free? Dealloc, it's called free. Alright, 121GW says he would honestly do it in reverse, since Java handles all the memory allocation for you, whereas you have to keep in mind in C and C++. He's guessing object-oriented is easier to master than he used procedural, but I've heard it called functional as well. Java does not handle all of your memory allocation and deallocation. You can get memory leaks in Java. It's kind of difficult to do it, but it does happen. Java handles a lot of the stuff, and Java protects you from other stuff that C doesn't. Like an array index out of bounds, which I showed today. C lets you write to an array that's out. C lets you write outside the bounds of an array. It lets you do that, and it doesn't give you an error. And if your program's big enough, usually it'll just crash your program immediately. But sometimes you'll have a bug that may take like an hour to manifest itself, and you can drive yourself nuts trying to find it. So Java's a very safe language, but with that safety comes overhead. Java will always be slower than C. Always. That's why most video game engines use C, or something that's built on C. Because Java has all these checks, like this person's trying to push to an array. Are they inside the array bounds? Checking whether you're inside array bounds takes computer time. It takes CPU cycles. So Java will always be slower than C, and that's pretty much Java's biggest downfall. It's a pro and a con. It saves you from a lot of mistakes, but it makes it a little bit slower. They started with C++ in Sweden for video game development. Yeah, C++ is used pretty commonly in game development for the reason I just stated, because if you have really good programmers who know what they're doing and they know about pointers and they know how to keep track and free their resources, then you can make a lightning fast engine. Python's easier than C++. I don't think it's just your experience. I think Python's just easier than C++. It is true Java's slow. Well, Java's not slow in general. I mean, checking whether you're inside or outside an array doesn't take that much time. I said Java will always be slower than C. That is true. Like, if the code is the same, if the implementation is the same, there are ways you can program something in C where C will be slower than Java. But I'm saying if you program two different algorithms the same way in both languages, the C way will always be faster. Just by a little bit. 121 GW says, I think there's a postulate that any sufficiently advanced program is merely an imperfect representation of a program in Lisp. I've used Lisp, so I get that. That's really funny. Lisp is a very interesting language. Most of the programming languages you'll learn will look like this. They'll look like Java, they'll look like C, they'll look like Python. Lisp looks different because you can send functions into parameters as objects. It's kind of weird to explain. But because you can send functions into other functions as parameters, Lisp can become a very good language to program AI in, because you can send behaviors into functions. I've programmed in Lisp and it's kind of fun, but it requires a different way of thinking. It's not object-oriented. I think Beeb is misunderstanding what I'm saying about Java being slow. Java is not slow. Java is slower than C, given the same algorithm. That's all I'm saying. Java is really fast. There are a lot of languages much slower than Java. Java is a really fast language. It depends on implementation. The reason it's fast is because not Sun anymore, it's Oracle. The Oracle Corporation, I don't actually know what type of group they are. Oracle now owns Java and maintains it, the language. They write the Java virtual machine for each system, and they have some interesting ways to speed up Java's processing. They have it, this JVM kind of learns shortcuts that it can use on the fly. It learns that if you're probably using a loop, you're probably accessing the same thing multiple times. It will actually cache things like that. So they have a lot of tricks that speed up the engine, that speed up Java, faster than it normally would be. But it will still always be slower than C. Or let me put it this way. I'll word it like this. The fastest algorithm for solving whatever problem, the fastest algorithm in C is faster than the fastest algorithm in Java. How often do I stream programming? Asks Ket. Oh man, Nektkong. I'm not gonna try to pronounce your name because I'm gonna get it wrong. I've been streaming every night this week, not including Monday, I think. I probably won't do it this weekend. I may, if I want to. These are mostly just going to be archived and transferred to YouTube for other people to watch in the future. If I do stream, it's going to be weekdays around 6:30 or 7 o'clock Central Time. That's 7:30, 8 o'clock Eastern US, which was about, what did I say? About 2 hours ago. I started 2 hours ago tonight, and I'll start about that time if I do it. I don't have a set schedule for doing this. I mean, there is a graphics engine. I like to plug it because I actually like it a lot. It's very good. There's a graphics engine that's done in Java. You can make games with it in Java, and you can get really good frame rates. It's called JMonkey Engine. If any of you are interested in game development, even if you don't plan on using Java for it, go check it out because it's kind of interesting. Like 8 years ago, maybe a little more than that, 10 years ago, nobody thought Java would be able to, nobody thought you'd be able to program a 3D game engine in Java. And now we have one. And it's very fast. So Java is fast. It's just not as fast as C, given the best implementation of whatever code you're running. And the only reason is because Java has overhead. overhead, just like business overhead, the cost of running a business, Java's overhead is the cost of protecting you from memory leaks, the cost of protecting you from array index out of bounds exceptions, things like that. I appreciate you guys watching. I really do. It's much more fun when there's chat interaction. I didn't know Twitch had a programming section either. I was actually teaching my friend some of this stuff a month ago or something like that. I wasn't streaming it, I was just teaching him, and I thought maybe I should stream me teaching him, but he's not on right now, so I just did it. I did it on Tuesday, I did it on Wednesday, and I did it tonight. Yeah, I just accidentally found Twitch's programming section. I don't know how I found it. I was probably just trying to make one up and one was already there. I think that's how I found it. Looks like the questions and the comments are dying down. I'm going to wait a little bit longer, see if anybody has anything else to say. Beeb says, I searched so long today for programming streams. Nobody wants to stream programming. Turpik says he finds this very helpful. I'm glad you find it helpful. But I'm looking for constructive criticism too. If there's anything that you guys don't understand, or if there's something I've said that you don't understand, or maybe you want me to explain things in a different way, I'd really appreciate that. Some of these videos I've been explaining in terms of making a game or doing something fun, like chess is a game. You might actually write code like this, you know, in an actual game. If you're making a computerized version of chess, you will write this kind of code. You know, I don't want to write solutions to generic math problems. The traveling salesman has to go to 10 places. What's the quickest route? You know, that's boring. All of the programmers are in the game development channel. I didn't know there was a game development channel. I didn't know there was a game development channel, and then Arpeggiatra says, oh really? No doubt making fun of my stream name. Yeah, let me actually go to Twitch and go to the, hopefully I won't bring up some random audio from the front page. How do I browse? That's what I want. Turpix is interested at the moment in data access objects. A data access object is really exactly what it sounds like. Why is the creative... There's a creative channel that has 57,000 viewers. What's going on in there? I've never seen this channel. It's number 3 on Twitch right now. It's people that like draw and paint and stuff like that. Yeah, that maybe it's new. Because I've never seen that on top 3. I haven't even seen it on like top 50. You say there's a game development channel. Oh, there is a game development channel. Stone Hearth dev stream? Is that like a Hearthstone for the web? That's what it sounds like. That's interesting. I didn't know that was up there. Maybe I will check this out a little bit. Bob Ross stream. I don't know if AJ is on. I'm sure he would not want a lesson twice in like 2 nights in a row. I mean, he's unemployed. He lost his job last week, unfortunately. So he's got... My phone's going off. Okay, sorry. Originally, that's the plan. I want to do one video series that keeps things more or less simple. I mean, if you guys ask questions that are higher level, I will try to answer them. I've answered every one that I have seen, except somebody asked once, what do I think of Spring? And in order to be nice to Spring, I didn't answer the question. But if you guys ask me stuff that's higher level, I will answer those questions. It's impressive that somebody is making a game using no existing code. They're writing the entire engine. Yeah. But anyway, yeah, this first introductory series, it's going to go through some basic stuff, learn basic programming. Like, if you check the archive, the videos are, let's see, one was like how to write methods, one was how to write a class, what's the difference between classes and objects. The one that I did earlier today was string manipulation. Like these are pretty simple concepts, but if you master just the basics, if you master how to write classes and objects, if you master string manipulation, if you master how to write methods and use them, you can make almost anything. Like the higher level stuff is mostly technologies. It's not learning how to do something in Java, it's learning how to use a particular library or how to use different libraries together. That's most of what the high level stuff is. One of these days I'll probably do synchronization. That's kind of a higher level topic, but it's interesting and it is easy to understand. And by the way, if any of you are interested in the music that's been playing for, let me check, the whole night and almost all of last night, I think, there's a very good, I guess he's Swedish? I don't actually know what nationality he is. He's a very good artist named Bjorn Lin. It's B-J-O-R-N. In fact, I'll type it. There's a very good artist by the name of Bjorn Lin who does nice, ambient, kind of calm, sometimes electronic music. Yeah, so this video has been winding down. It looks like chat has slowed down and you guys are out of questions. So I'm going to go ahead and call it a night. Like I said, if you guys want to see something specific that is Swedish, okay, I thought so. Yeah, that makes sense to me. Anyway, if you guys have any recommendations for a little small project that I can do on stream that you'd like to see, I mean, please don't make it like a homework assignment for one of your classes, right? I'm not going to do your homework. I can tell the difference. But if there's something cool that you want to see me do, package organization, I'm not going to talk about package organization. That's not really something that's important to know, because quite honestly, although it's good practice to divide your classes into their own packages based on, you know, how they belong together, that doesn't really change your program. Alright, well, like I said, I'm gonna go ahead and stop it because I'm tired. I actually woke up late and got to work late today. Luckily, both my bosses were out today, so nobody noticed. But anyway, I'm gonna go ahead and call it a night. Like I said, I probably won't do this over the weekend, but I will try to do it next week. Also, I ran out of ideas for this week. Like, this is the only thing I had left that I had thought of. Do something like Tetris. I actually have tried to do a, I don't know if you guys have heard of this. I was addicted to it for a while, but there's a game out there called Not Tetris. That's what it's called. It's called Not Tetris. And what it is it's Tetris, but instead of the blocks being rigid on a grid, they're physics-based, so you can rotate them at arbitrary angles. It's not all 90-degree angles. You can rotate them at arbitrary angles. You can move them, you know, granularly left and right. They're not stuck on a grid. And they react like objects would react in the real world. So if they're on a slope, they'll slide down the slope. It's a really interesting take on Tetris, and I tried to make something like that. I didn't try very hard. I did like 100 lines and quit. Yeah, something like Tetris would be interesting, but no, maybe. We'll see. The problem with doing anything visual-based is I have to introduce a graphics library or some kind of user interface. That's why I've stayed away from tic-tac-toe. Because programming tic-tac-toe is pretty easy, but you need to use something like Swing or a graphics engine to do it. So that's why I didn't do tic-tac-toe. Alright, but anyway, I've been going longer than I wanted to. So I will see you guys hopefully next week. I plan to continue this. I don't know what I'll continue it with. I'll think of something over the weekend. But thanks for joining me. I really appreciate it, you guys. It's way more fun when there's audience participation. Alright, thanks a lot, and I'll see you guys next week.